All right, so today we're moving on to our next chapter. We're going to be working with similar polygons. And it says the definition of similar polygons are two polygons that are similar if their corresponding, meaning matching, angles are congruent, and their lengths of the corresponding sides are proportional. So we're going to see what proportional looks like. And the symbol for similar is that tilde symbol. Looking on your keyboard, you would see it's where your numbers are at the top, all the way to the left by number 1. That's our similar symbol that I call tilde. All right, so now we're going to see using similarity statements. So it says list all the corresponding angles and then write the ratios of the corresponding lengths. So we're going to start with corresponding angles. This is something we've done before, so we're just matching part for part. So here I can say angle A is congruent to angle W. They're both in the first position of the names, so they should match. So that means I'm going to follow angle B congruent to angle X, angle C congruent to angle Y, and angle D congruent to angle Z. Again, doing this without a picture, you should be able to read that statement without a picture. All right, so now we're going to look at making that ratio. Remember, a ratio looks like a fraction. All right, so we're going to set that up. I have 4 letters in both polygons. That means I know I have a 4-sided figure, so I'm going to set up 4 ratios. And the ratios should be equal to each other. So I'm going to start my first picture in one color and my second in another, just so you can see where they're matching. All right, so in the first one, I'm going to label here, my first side is AB. What would be the first side in my other polygon? That would be WX. All right, and I'm going to continue that on throughout the entire ratios that I'm creating. So then I'm going to say BC and XY, CD and YZ, DA and ZY. ZW. All right, so those are my 4 ratios for the corresponding lengths. We're going to see what that looks like when we have values to put in with it. So moving right into our next example, it says to compare the similar triangles. So it says triangle ABC is similar to triangle DEF. So I'm going to look at my triangles from left to right, just in this example. All right, so we're going to create this ratio to help us. All right, so again, I'm going to create, here we have 3 letters, so I'm going to create 3 ratios here. So here I have 1, 2, 3. So I have AB, and that will be going over DE, BC over EF, and then CA over FD. Now, we're not done. That was just kind of like what we just did. So what the next step is, we are going to use the numbers that we have. We're going to plug in numbers. So AB is a side length. So I'm going to go to my diagram, and here is AB. So it's going to be 5 over, and then I look up the value for DE, and that's 5 over 10. I'm going to continue that process throughout. So again, looking at my diagram, BC is the value of 4, EF is the value of 8, CA is 3, and FD is 6. Now, here we do have fractions. We do not leave it like this. We need to take it one step further, and we need to simplify. So we can see that we have 1/2, 1/2, 1/2. So because all 3 ratios are the same, meaning they were all 1/2 here, the lengths of the corresponding sides are proportional. We can prove that these two triangles are similar because when we looked at all the ratios, they all came out to the same value. And we're going to call that value our scale factor. All right, so let's look onto our other side. All right, so bringing in that scale factor, that common ratio that we just saw, again, we refer to as our scale factor. The scale factor is that common ratio. We do have a formula. Our formula is that our scale factor equals our image over our pre-image. Now, we're going to talk about what that means. So, image means our new picture. Over our old picture. So that does matter. We have to pay attention to how we're reading it. And then the letter for scale factor is the letter K. All right. So let's look at the next example. It says to try on your own, but we're going to try that one together, pausing every so often. So it says in the diagram, triangle JKL is similar to PQR. Okay. So we're starting with JKL. So this is my first picture. Am I going to call that my image or my pre-image? Right? We're going to call that our pre-image. Which means my new picture here is my image. Now, how did I get that? I got that from my similarity statement. This came first, then this came second. So I'm reading it in that order. So we're going to follow that order from our original to our new picture. And that's going to help us set up what we need. So just by looking at this picture, does our picture get bigger, an enlargement, or is it a reduction? That's what we should be thinking about to figure out our value of K. As you can see up here, K, if my value is larger than 1, it's going to be an enlargement. If it's between 0 and 1, it's a reduction, meaning it got smaller. All right, so now it wants us to find two things in this problem. It says find the scale factor from JKL to PQR. So we're going to start there. I'm splitting my paper in half because there are two parts. So I'm going to do that over here. So to find the scale factor, I need to help myself with the corresponding lengths to do that. All right, so here, remember we want our image over our pre-image. So that's going to be triangle, again, PQR, we have it labeled on our picture, but I'm doing it again, over JKL. So that means the PQR values are going to be in the numerator, and JKL is going to be in the denominator. Very important. All right, so we're going to set up our ratios like we did in our previous problem. So here, again, we have 3 letters, 3 ratios here. So 1, 2, 3. So I have PQ. Again, I'm using the similarity statement more than just using the picture because that helps me where to begin. So PQ matches or corresponds to JK. Then QR goes to KL. And then RP goes to LJ. All right, our next step is to plug in numbers. So that means we're going to go to that diagram and plug in our numbers. So here we'll have PQ is 9, JK is 6. And then continuing on, we have 6 over 4, 12 over 8. Again, remember, image over pre-image. So now, reading this, I want you to determine what is the scale factor. Take this one more step, like we did in the previous problem, and figure out what is the scale factor. All right, so I can reduce, and when I do, I get 3 over 2 each time. So that means my scale factor, let me put it over here, is my scale, 3 over 2 is my scale factor. Your scale factor is that same number that repeats over and over again for each of your sides. That's meaning it's proportional. It's proportional by 3 over 2. All right, and then the last part, it said that it wanted us to not only find the scale factor, it wanted to list the corresponding lengths, which we already did. These are our corresponding lengths. So I'll label that. And then they want us to list our corresponding angles. So here we have angle J is congruent to, and what is angle J congruent to? Again, use your similarity statement. The diagram only helps but so much. That would be angle P. Angle K is congruent to angle Q. And then angle L is congruent to angle R. All right, let's try another example. It says, now we're going to determine if we have similar figures. Before it's telling you we did, now we're trying to see if we do. So we have a little bit of a process when we need to determine. First, we need to check that we have corresponding angles that are congruent. That is the very first thing you want to check. You want to check that all the angles are the same, because if they're not, if we don't have the pairs that we need, then we're done. We don't need to continue to the next step. Then the next step, if that does work, is we're going to check that all the corresponding sides are proportional. All right, so let's look. It says determine if rectangle ABCD is similar to rectangle EFGH. And what is the scale factor? So the first thing, again, is we're going to check angles. We're going to check if they're congruent. All right, so there's no angles labeled in this diagram. They want us to know that remembering a rectangle has right angles. So a rectangle, by definition, has 4 right angles. So I can put those right angles on my diagram. All right, so looking at the diagram, does this meet number 1? Are all the angles, pairs, congruent? Does A match E, B match F, G match C, and so on? Does that work? And the answer is yes. So now we're going to move on to number 2, and we're going to check if the sides are proportional. All right, so again, remember how we read this. This is our original image, and this is our new image. So we're going in this direction. So looking at this picture, I'm going to label my very first picture. What am I going to call this? Is this my pre-image or my image? All right, this is my pre-image. This is what I started with. And this is my image. Now that's going to help us set up our ratios and find our scale factor. So let's set up our ratios. So starting again, I'm starting with using my similarity statement, and we use our second one first. So I'm using EF over AB, FG over BC, GH over CD, HE over DA. Right, so that is my setup. Now I'm going to plug in my numbers, referring to my diagram. Now I'm putting a question mark over the equal sign because I don't know if my ratios are congruent to each other. We have to check that. And we want to reduce wherever we can. So I do want to reduce a couple fractions. I can reduce 2 of them. So I want to reduce them. So going one step further. So I have 1 over 2. Okay, so here are my 4 fractions. Are they all the same? If they are all the same, we have a scale factor. If they are not all the same, we do not have a scale factor, and then that means our rectangles are not similar. So do we have a scale factor? No, we do not. Not all the same number. So again, that means we have to write not similar because not proportional. You need to write the statement. The statement is huge. If you don't write the statement, you didn't finish the problem. Now, I use the symbol for similar. You can write the word out. All right, we're going to try another one. All right, so here we have a pentagon, and I gave the information that the inside angles have a sum of 540 degrees. Okay, so that's the very first thing I want to tell you. And then it says they want to know if these two are similar. So we're going from left to right since they didn't name anything. So I want to know, what am I going to call this figure that I'm pointing to? Is this my pre-image or my image? Okay, this one came second. This one is the image. I'm going to label it with an I because I can't put that in there. Making the first one my pre-image. All right, so the very first thing you need to do is you need to figure out the missing angles. So I'm going to highlight. There's a missing angle here and a missing angle here. They're two separate problems. I want you to pause your screen. I want you to use the information of 540. All 5 angles inside should make 540, so you need to find that angle. All the angles in the second pentagon make 540, and you need to find that missing angle. All right, so the very first angle here and the smaller one is 80 degrees. I did that by adding up my 4 angles that I do have and subtracting from 540. Repeating the same process for the next pentagon. This angle in the corner is 120 degrees. All right, so now again with our steps, we check our angles. They all are congruent. All 5 of them match. All right, now we're going to talk about proportional sides. There are no letters for this one, so I'm going straight into numbers. I'm picking a place to start from. Now remember, when we're setting this up, it's going to be our image over our pre-image. Order does matter. So the numbers in the larger one for this problem are going on top. So I'm going to start with 15 and work my way around. So I'm starting right here and going in this direction, which means I'm going to start the same place and follow in the same direction. So I have 15 over 6. Is that congruent to 15 over 6? Is that congruent to 20 over 8? So again, I'm going back and forth, matching up my side lengths. Is that congruent to 25 over 10? And is that congruent to 20 over 8? So remember, we need to take that moment. We need to simplify wherever we can. And I can simplify all of them. So when I do, I get 5 over 2 for each one. So now if each ratio is 5 over 2, what is the scale factor? Right, the scale factor is 5 over 2. So yes, the figures are similar. And K equals 5 over 2. Again, I'm using my letters, my vocabulary. K represents scale factor. All right, so now we're going to go and incorporate our triangles with this. Let's turn our page. All right, it says finding corresponding lengths in similar polygons. So here it says in diagram DEF is similar to MNP. What that means, this statement tells us a lot of information. It tells me that my angles are congruent. It tells me my sides are proportional. So I know my sides should match. So we are going to use a proportion to help us. We are going to set up a proportion. Now, there are 3 sides, but for a proportion, we only need 2 fractions for that. So we don't need all 3 sides to help us. And then we are going to cross multiply and solve. All right, so the very first one is I want to highlight the side that has x. So EF matches with, and I'm looking at my similarity statement, matches with NP. So I know that I have to use those two. Now the other pair I pick does not matter. That is up to me for what I choose to pick. So I'm going to pick these two sides. So I'm going to create my proportion. So I go from left to right. So I'm going to say 30 over x, so yellow over yellow, equals 18 over 15. Now we're going to cross multiply. So when I multiply in this direction, this makes 18x. And when I multiply in this direction, it makes 450. And now we have an equation we can solve. We want to get x by itself, so we're going to divide both sides by 18, making x equals 25. Right? And we're done with that problem. All they wanted to do was find the missing side length here, and we did that. All right, and then example 3. It says, in the diagram, triangle TPR is similar to XPZ. Find the length of the altitude. Altitude means height. So we want to find the height. All right, so the height here is not labeled. This is our height that's missing. So make sure you label your height. So we have two triangles. Here's one. They're actually showing the height. Here's the other triangle they're talking about, showing the height. So again, we want to use certain things. So first, we want to use the height and the height. So I'm going to write that as a fraction first. So here I have x over 20. And then, looking at the triangle, there's two ways to set up this. I'm going to set it the way I think is easier. So here we have the base of the triangle and the base of the triangle. How much is this base? Well, the base goes from T to R. That means I'm adding the two numbers, and that makes 12. And then here, I'm adding the two, and that makes 16. So now I'm going to cross multiply. So here, when I cross multiply, I have 16x. And then in the other direction, I'm multiplying, and I get 240. And then we divide by 16. And x equals 15. Now, you could have used 6 and 8 to create that fraction, but I like to be consistent, and I like to use the entire base. That was just a preference. All right, so we're going to continue more practice. If you have questions, let me know.